Hey everyone, it's that math magician, and on this video, I would like for us to talk about permutations. Now you might not be familiar with that word, but my hope is that by the end of this video, you'll have a solid definition of a permutation and you'll be able to spot it out when you're looking at different scenarios. So first things first, we need to write out what is the definition of permutations. Now our book has a nice formal definition where they say a permutation is an arrangement of items in which the order of selection matters and items cannot be selected more than once. What I'm going to do is I'm going to go ahead and shorten that up a little bit just because I don't want to write out this big, heavy, formal definition. So here's what I would like to say permutations are. Permutations are an arrangement of items where, and here's the most important part, right? There's two deciding factors here. The first is that the order of selection matters. Well, I'm going to write that just as where order matters. And items cannot be selected more than once. A smaller, simpler version of that is just saying that you cannot repeat. There can be no repetition of an item. So I'm going to write no repetition. And this is going to be the definition that we're going to work with as we move through this video. Permutations are just an arrangement of items where order matters and there's no repetition. Now we're going to look at an example of license plates being made out of the letters A, B, and C. So we get provided this nice table that has all of the different possible arrangements we can use for the letters A, B, and C on license plates. And I'm going to go ahead and just label this license plates just so I remember what these are referring to. And we can see that we could have an arrangement of AAA, BAA, BAB, and so forth. We see all the different possible ways we can do this using the letters A, B, and C. And now we want to think about another scenario. And so let's think back to when you were a child and you used to play with those magnet letters on your fridge or some other whiteboard. And we want to think about what if we had three magnet letters where we had an A, a B, and a C. And I'm going to label these magnets so we know the difference. And they want you to think about what are all the different possible combinations you could make out of those three different letters. And so what I'd like you to do now is kind of to pause the video, and I'd like you to write out a list of all the different ways you can arrange A, B, and C if you're imagining that you have only those three magnets to work with. So go ahead and pause the video and then make your list, and let's see if your list will match mine. Okay, so here's how my list is going to look like if I'm using these three magnets to create different combinations. I have A, B, and C, which is kind of the easy one. And then my next one, I could just swap these two letters, the B and C, to create A, C, B. And then there's really no other way for me to arrange these so that I have the A first. So now I'm going to switch and write the B first. And so I'll make the word, let's see, back, B-A-C. And again, I'll swap these last two to create B-C-A. And then again, right, there's no other way for me to arrange these with having the B in front. And last but not least, we'll have C-A-B. And then I'll swap the A and the B, and I'll end up with C-B-A. So these are all the different outcomes I have when I'm arranging only three magnets, A, B, and C. Now looking at these two different scenarios, right? They're very similar, but there is a minor difference. And I want you to look at these lists and try to figure out what is the difference between these two lists. Hopefully we can see that with this first list of my license plates, we allow repetition. So I'm going to go ahead and just make a little note that says with repetition. Because as you can clearly see, we have AAA, BBB, CCC, AAB. We are allowing repetition in that list. Now, when we're dealing with magnets and we only have one magnet for A, one magnet for B, one magnet for C, there really is no way to allow repetition because I don't have multiple magnets of the same letter. So on this list, it's without repetition because we just don't have multiple magnets. Now, looking at these two different lists we've created, one where we have license plates, one where we're using magnets, which list or which scenario do you think fits our definition of permutation? Hopefully, you're looking at the definition and you see what hopefully it's very obvious that the magnet scenario, this is a permutation. And one of the main reasons why this is a permutation is because there is no repetition. We said back up here in our definition that the arrangement of the items where order matters and no repetition. This is a permutation. When we're dealing with this list for the license plates, this is not a permutation. And hopefully this is starting to have you realize these subtle differences for these two different scenarios, and we can start to see why one is a permutation and why the other one isn't. So let's look at one more example before this video ends to really solidify our definition of what makes a scenario a permutation. So what I'm going to do is I'm going to go ahead and draw around my definition of permutation because I want to copy that and I want to slide it down here so we can continue working with this nice definition that we have of what makes a permutation a permutation. So our next scenario says that we have 8 candidates who want to become president, vice president, and secretary. So I'm going to go ahead and write that out. We have 8 candidates where one will be president, one will be vice president, and one will be the secretary. Now we have another scenario, and the other scenario is that we have 8 applicants where 3 are going to be selected to be on the spirit committee. So 3 selected for committee. I'm going to just abbreviate committee to com. Okay, so we have these two different scenarios where the first one, we're going to have 1 president, 1 vice president, 1 secretary. And the other scenario where we still have 8 people applying is that 3 are going to be selected for committee. And the question asks is how are these two different lists, how are they going to be different from each other? And which one do you think is going to be longer? So here's what I would like you to do. I'd like you to think about what if we had 3 different students being selected. Okay, let's focus on just 3, right? Just 3 of these 8 candidates. Let's say one of them name is Liz, the other's name is Sam, and the other name is Jose. Now, we want to figure out and start to think about how these lists might differ. Now, if we're looking at this first scenario here, right? I'll label this 1, I'll label this 2. If we're thinking about this first scenario, where I'm looking at Liz, Sam, and Jose of the 8 candidates, right? There's 5 other people, but we're just going to focus in on these 3. We have where 1 will be president, 1 will be vice president, 1 will be secretary. Well, so for the first scenario, I could have Liz be the president, Sam be the vice president, and Jose be the secretary. But I think I could also flip that and maybe have Liz still be the president and Jose be the vice president and Sam be the secretary. And then I think I can also even flip that a little more. And what if now instead of Liz being the president, Sam's the president, Liz is the vice president, Jose's the secretary. And then again, I could flip these last 2 and have Sam as the president, Jose as the vice president, and Liz as the secretary. And I'll go ahead and label these as the president, the vice president, and the secretary. Hopefully you can see that on number 1, the order matters here, right? The order that I list these students out it definitely matters, because in this first scenario, Liz is in the first spot, so she's the president, and Sam's the vice president, and Jose's the secretary. On this scenario here, this is different, because now Jose's the vice president, and Sam's now the secretary. So their roles were switched. If we look at, let me label this one in green. If we look at our second scenario, where I'm just picking 3 people to serve on a committee, there's really no roles for these students to have. They're just all working together. So if I list out Liz, Sam, and Jose to work on a committee where there is no role, that's no different from me writing Jose, Sam, and Liz, because it's still the same people being chosen, right? It's still the same people being chosen. It doesn't matter how I select them, who's first, who's second, who's third, because they're just going to be on the committee working together. Versus over here, the order does matter, right? The order matters because one's the president, one's the vice president, and one's the secretary. So let's go ahead and make this note that on this scenario here, order matters because someone has to be the president and so forth. For this scenario number 2, where I'm just selecting 3 people to work on a committee, where there really are no roles, I'm just picking 3 students, the order here doesn't matter. Now, I'm going to try and zoom out so we can get back to our definition of what makes a permutation a permutation. Looking at those 2 different scenarios, which one do you think ends up being a permutation? Hopefully we see that it is the first scenario that is a permutation. I'm going to go ahead and mark this out. Let me get a nice color here. This guy is the permutation. And the big reason why is because order matters. This second scenario is not a permutation because the order doesn't matter here. I'm just selecting 3 students. There are no roles. It doesn't matter who gets chosen in what order. Okay? Hopefully, these 2 different examples that I showed you, where we had our license plates and we had people being chosen, helps you realize the definition of a permutation. Permutations come down to 2 distinct qualities. The first is we cannot have repetition. If there is repetition, then it's not a permutation. Only scenarios without repetition will be permutations. And only scenarios where the order matters is that going to be classified as a permutation. All right, hopefully this helps to serve as a nice little intro to permutations. I will be making more videos during the week to kind of build on these definitions that we just created. All right, guys, I'll see you next time.